This lesson shows how to graph the rational function 4x over x squared minus 4. In previous lessons, you've learned about the four important parts of a rational function. The vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line the graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals 4x over x squared minus 4 and variations of the function. The VAs are the zeros of the denominator. The denominator factors as x plus 2 times x minus 2, so the function has two VAs at x equal negative 2 and x equal positive 2. For this rational function, the numerator is degree 1 and the denominator is degree 2. Since the degree of the numerator is less than the degree of the denominator, the HA for the function is the horizontal line y equals 0, the x-axis. To find the y-intercept, evaluate the function for x equals 0. This gives 0 over negative 4, which is 0. So the y-intercept for the function is the point 0, 0, the origin. The x-intercept is the 0 of the numerator. So set the numerator equal to 0 and solve. You get x equals 0. So the y-intercept for the function is the point 0, 0, the origin, which is also the y-intercept. Next, calculate at least one point on either side of both VAs. Starting at the left, for x equal negative 3, y equals negative 12 over 5. And so there's a point at negative 3, negative 2.4. For x equal negative 1, y equals negative 4 over negative 3. And so there's a point at negative 1, 4 over 3. For x equal 1, y equals 4 over negative 3. And so there's a point at 1, negative 4 over 3. For x equal 3, y equals 12 over 5. And so there's a point at 3, 2.4. Finally, sketch a graph of the function. Since the x-intercept is not on this side of the VA, from this point, the graph can't curve up because there would be an x-intercept. So the graph must curve down towards the VA and up from below towards the HA. Between the VAs, you can see from these 2 points, the graph is increasing towards the left-hand VA. So the graph must curve upwards. From these 2 points, you can see the graph is decreasing towards the right-hand VA. So the graph must curve downwards. Finally, from this point, the graph can't curve down because there would be an x-intercept. So the graph must curve up towards the VA and down from above towards the HA. So sketch the graph of the function like this. Here are some variations of the function. If you increase the constant in the numerator, the graph stretches vertically. For example, notice how this part of the graph is higher. If you make the constant smaller, the graph shrinks vertically. For example, notice how this part of the graph is lower. If you replace the constant 4 with -4, the graph is reflected vertically. For example, notice how this branch of the graph has been flipped over and is now in quadrant 4. If you change the factors in the denominator, you can shift the VAs. In this example, the VA at x equal 2 is now at x equal 3. This lesson showed how to graph the rational function 4x over x squared minus 4. And the lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.